The trowel scrapes into a wall of pale, wind-laid silt on a low terrace above the lower Salmon River in the canyon country of Idaho County, western Idaho. Lauren Davis kneels close to the cut face, brushing sediment away from a slender piece of worked stone. It is a stemmed, projectile point, narrow at the base where it was meant to be lashed to a shaft, and it is nothing like the fluted Clovis points that are supposed to mark the very first Americans. It is sitting in a layer that has not been disturbed since the last ice age, and it is buried below the level where the story of human America is supposed to begin. This is Cooper's Ferry, a site the Nez Perce know by an older name, Knife, an ancient village at the mouth of Rock Creek where it meets the Salmon River. For most of a century, the rule in American archaeology was simple. People arrived around 13,000 years ago, walking down through a corridor that opened between two ice sheets, and the first of them carried the Clovis spear point. If the stone in Davis's hand was as old as the dirt around it, then someone was living at this bend in the river before that corridor had opened at all. The road everyone agreed on would not yet have existed, and these people were already here. Lauren Davis is an archaeologist at Oregon State University in Corvallis. He first dug at Cooper's Ferry in 1997 as part of his doctoral work, and what he found even then was unsettling. In a small pit, he uncovered a cache of stemmed points, tools that did not belong to the Clovis tradition, with radiocarbon dates suggesting they were up to 13,300 years old. That was already close to Clovis, close enough to make people uncomfortable. Davis had lingering questions. So a little over a decade later, he came back. He returned to answer one question in particular. He wanted to know whether the tools he had found in the 1990s were actually older than Clovis, or whether he had been fooled by a complicated site. To find out, he opened a much larger excavation and ran the chronology properly. In the science of dating, that means two methods working together. The first is radiocarbon dating, which measures the slow, steady decay of carbon-14 inside anything that was once alive: charcoal from a hearth, bone from a meal. The second is optically stimulated luminescence, which does something stranger. It measures the last time a grain of sediment saw sunlight, the moment it was buried and the clock started running. Davis and his team ran both, on samples from the deepest cultural layer, and then fed the results through a statistical model to tighten the range. The lower layer at Cooper's Ferry came back between roughly 16,500 and 15,300 years before present. That was the number that changed everything. Davis has said plainly that when he first saw radiocarbon ages older than 14,000 years, he was stunned and skeptical, and that he needed to see the numbers repeat over and over before he would believe them. So they ran more dates. The lower layer held, set that number against the textbook. The Clovis first model placed the first Americans at roughly 13,250 years ago. Cooper's Ferry pushes human presence back to around 16,000 years. That is a gap of more than 2,000 years, opened up not by speculation but by charcoal and buried sand. And 2,000 years, at the threshold of a continent, is the difference between one migration story and a completely different one. What came out of the ground was not a single lucky artifact. Across the excavation, Davis and his colleagues recovered close to 200 stone artifacts from the lower levels: stemmed projectile points, sharp flakes, blade fragments, and the broken bones of large mammals that had been processed for food. These were not scattered randomly through the soil. They clustered around fire hearths and inside deliberately dug pits, the ordinary furniture of a place where people actually lived, cooked, and worked. This was a camp, returned to again and again. The Nez Perce name for it, Knife, describes exactly that. a village occupied for a very long time. But that's only part of it. The particular shape of these points carried a second surprise. They were stemmed, made with a tang at the base, and they closely resembled late Upper Paleolithic tools from the far side of the North Pacific, from sites in Hokkaido in northern Japan. Stone tools do not usually cross an ocean of time and distance and stay recognizably similar by accident. To Davis, the resemblance suggested something about where the makers had come from, and by what route. Not down through the frozen interior, but along the edge of the Pacific, hugging a coastline that led from Northeast Asia to the Americas. The first mainstream reaction was not acceptance. It was a hard, specific question. Ben Potter, an archaeologist at the University of Alaska Fairbanks, pointed out that it was not clear the oldest radiocarbon dates at the site were truly associated with human activity, rather than with older material that had ended up in the same layers by other means. That objection was fair, and it would not go away. To answer it, you have to leave Idaho for a moment and look at what else had been surfacing across the Americas at the very same time. Travel thousands of miles south to a waterlogged site in southern Chile called Monte Verde. There, the archaeologist Tom Dillehay excavated the remains of a settlement preserved in a peat bog, wooden artifacts, hearths, the foundations of dwellings, even fragments of plants carried in from the coast. The date settled at roughly 14,500 years ago. What matters about Monte Verde is not that it is contested. What matters is that it is accepted. It is one of the sites that finally broke the Clovis first consensus, and the mainstream of the field acknowledges it. Here's where it gets specific. If people were living in southern Chile 14,500 years ago, then the tidy walking route fails on arithmetic alone. The ice-free corridor through the interior of North America did not become a survivable passage until later, and a small population could not have strolled from Alaska to the bottom of South America in the narrow window left over. The math does not close, but a coastal route does close it. People moving by water down the Pacific edge, living off the astonishingly rich shoreline, could cover enormous distances without ever needing the frozen interior. Monte Verde does not prove Cooper's Ferry. It does something quieter and more powerful. It makes the coastal explanation for Cooper's Ferry look ordinary rather than radical. And then there is the genetic thread. If the first Americans came down the Pacific Rim, then their bodies should carry a record of where that rim began. They do. Geneticists studying mitochondrial DNA, the small loop of genetic code passed down only through the mother, in an unbroken line across tens of thousands of years, have traced particular Native American lineages back toward their nearest relatives in Northeast Asia. Some of the closest sister branches sit along the northern coast of China, and a parallel branch of the same broad family reaches toward Japan. That is the same corner of the world the Cooper's Ferry points seem to echo. Here is why that convergence is hard to wave away. The stone tools and the genes were studied by completely different people, in completely different disciplines, using completely different evidence. An archaeologist comparing the shape of a projectile point has no connection to a geneticist reading mutations in maternal DNA. And yet they point back toward the same broad region of the North Pacific. It is important to be careful here, and not to overstate it. This does not prove that the people of Cooper's Ferry sailed directly from Japan, and it does not make them a single tribe on a single boat. What it does is line up two independent arrows from two unrelated fields, and both of them point to the same coast. If this is the kind of story you want followed properly, the sites the textbooks are still catching up to, the dates and the digs and the people who staked their careers on them, this is the channel that tracks them as the evidence comes out of the ground. Subscribe and follow along, and you will know the moment the timeline moves again, because it has moved before. and it has cost people dearly. To understand what Lauren Davis was walking into when he published a 16,000-year date, you have to understand what happened to the last man who dared to claim a site older than Clovis in the far north. His name was Jacques Cinq Mars, a Canadian archaeologist, and between 1977 and 1987, he excavated 3 small caves in a limestone ridge above the Bluefish River, roughly 54 kilometers southwest of the community of Old Crow. Among tens of thousands of animal bones, horse, caribou, mammoth, he believed he saw the cut marks of stone tools, and when the bones were dated, some reached back astonishingly far, well beyond the Clovis threshold. He said so publicly, and for that, the field turned on him. In the world of Clovis first, a site twice as old as the accepted limit, in a place with few obvious tools and no clear ancient hearth, was treated not as a discovery, but as a mistake, or worse, as a cautionary tale about wanting something too badly. Cinq Mars watched his findings dismissed for decades. Funding grew difficult. The site slid out of the conversation, and the man himself grew bitter, convinced the establishment had refused to even look honestly at what he had found. Then, someone looked again. A younger researcher, Lauriane Bourgeon, went back to that same collection of bones, still carefully preserved in storage, and examined it with modern methods and strict criteria for what counts as a genuine human cut mark. Across painstaking microscope work, she identified unmistakable butchery marks made by stone tools on the bones of Ice Age animals. When the samples were radiocarbon dated, the results confirmed a human presence in those caves reaching back around 24,000 years. In 2017, Bourgeon and her colleagues published that vindication. Cinq Mars had been right the entire time. He lived to see it before he died in 2021, though the decades of professional cold could never be given back. Lauren Davis is not a martyr in that mold, and it would be dishonest to make him one, but he knew the terrain. His own first find at Cooper's Ferry back in the 1990s had been controversial precisely because it edged up against Clovis, and he returned to the site partly to test whether he had deceived himself. This time, rather than wait to be believed, he did something decisive. He went and dug a second, physically separate excavation. That second dig is called Area B on the eastern side of the site, and it matters because of exactly what the critics were about to say. In 2022, Davis and his team published the Area B results in the journal Science Advances. The separate excavation produced its own cultural pits, its own artifacts, and its own radiocarbon chronology. In the early ages it returned were statistically comparable to those from the original excavation in Area A. 2 separate areas, dug at different times, telling the same chronological story. Now the counter-argument deserves to be laid out fully and fairly, because for a long time the caution was not stubbornness, it was good science. The principle that extraordinary claims require extraordinary evidence exists for a reason, and a single deeply buried layer, riddled with complications, is exactly the kind of evidence that should be interrogated hard before the textbooks are rewritten. The most detailed challenge to Cooper's Ferry came from the archaeologist Stuart Fiedel and several colleagues. In an essay published in the journal Paleoamerica in 2020, their objection was specific and technical. The sediments at the site, they argued, are heavily churned by rodent burrowing, a process called bioturbation, in which small animals tunnel through soft ground and drag material up and down through the layers. In such a site, an old bone can be carried upward, and a young one dragged down, until the neat relationship between an artifact and the dated material around it comes apart. They pointed to a single pit, in which one bone dated to around 16,000 years, while another piece, higher up, dated to around 11,500. If burrowing animals had scrambled the deposit, they argued, then the oldest dates might not mark the arrival of people at all. It is a serious, disciplined objection, and it names a real process that genuinely occurs. Here is the one detail that objection strains against. Bioturbation is, by its nature, random. Burrowing animals do not coordinate, and they do not reproduce the same false pattern in 2 separate parts of a site dug years apart. Yet the second excavation, Area B, returned early ages statistically comparable to the first. Random mixing does not easily explain two independent areas agreeing. So lay the lines side by side and look at what is actually holding the claim up. There is the archaeology, the stemmed points, and their resemblance to Upper Paleolithic tools of the northwestern Pacific Rim. There is the geochronology, the radiocarbon dates on charcoal and bone paired with the luminescence dates on the sediment itself. There is the geology, the buried soil in the canyon, the Rock Creek soil, which has been dated at multiple localities up and down the lower Salmon River and brackets the site's age independently of the artifacts. And there is the internal replication, Area B confirming Area A. Around that core sit the corroborating pressures from outside Idaho entirely, an accepted site in southern Chile that only makes sense with a coastal route, and a genetic signal that points back toward the same North Pacific coast the tools evoke. No single one of these is a closed case on its own. That is not how this works. But they do not fail in the same direction. The typology, the chemistry, the sediment, the second excavation, the southern site, the maternal Dina, each rests on a different foundation, and they lean toward the same conclusion. Not that a single textbook page was wrong, but that the whole shape of the story has to change. People were south of the ice before the interior corridor opened. The most economical explanation is that they came down the Pacific coast, and that when they reached the mouth of the Columbia River system, they found their first easy way inland, up the rivers, to a bend in the Salmon River called Knife. Cooper's Ferry is one of the anchors holding that new shape in place. And yet the thing that would settle the deepest question is still sitting in the ground, and still sitting in storage. The terrace at Cooper's Ferry has not been fully excavated. Beyond the areas Davis has opened, there are adjacent deposits in the same alluvial terrace that remain untouched, and there is more than that waiting indoors. Davis has said his team has something on the order of a decade's worth of already excavated artifacts and samples still to be fully analyzed, material lifted from the earth but not yet worked through in the lab. The single most important comparison, the direct, artifact by artifact matching of the Cooper's Ferry, stemmed points against the assemblages from Hokkaido that they appear to resemble, has not been carried all the way through. That comparison is the hinge on which the coastal, trans-Pacific hypothesis turns. And it remains a hypothesis precisely because the detailed work is unfinished. The reason it stays unresolved is not a conspiracy and not a locked gate. It is slower and more ordinary than that. The analysis of a decade of material takes years of funded, patient labor. The bioturbation critique keeps the association between the artifacts and the oldest dates formally open, which means every new claim has to be defended sample by sample. And the trans-Pacific comparison depends on cross-referencing collections held on two different continents, in two different research traditions, one of them published largely in Japanese. The evidence exists. The hands and the hours to finish reading it do not yet. The rest of Knife is still in the terrace, and the tools that could tie it to the far side of the Pacific are still in their trays, waiting to be read.